All right, here's our first video in practice problems on lesson 2-2. So what we're looking at is starting off in question 1, explaining in our own words what is a radian. So I've already put that in just because it takes a long time to write all that out. But what I would say is a radian is the measure of the angle whose arc length, that green in this picture, the length of this part, if you were to walk around the circle, is equal to the radius of that same circle. So whatever the distance of this radius, if you were to like take a piece of string and measure that out and then lay that string around the circle, whatever that distance of the radius is, if you were to make an arc go up that same distance, the angle that you are creating, let me let's choose, I don't know, purple, pink, there we go. So if I were to come down and draw in this angle, that would be 1 pi radian, we call that. So anyways, that's how you figure out a radian is just whatever. So no matter how big or small your circle, the radius changes, the arc length will kind of stay the same in that regard, and that's how we can kind of keep it consistent. So a radian is the measure of the angle that has the arc length equal to the radius of the given circle. Number 2, moving on. And these go up and down, then up, down. So 2 is here, 3 is below it. All they're asking us to do is draw the angle with a given radian measure in the standard position. So the thing to note about radians is that if you were to continue drawing these, let me draw this green guy here. If I were to continue drawing another arc length, there's another one here, another one here, and then another one here, and then we just keep going all the way around the circle, right? So 1, 2, 3, 4, 5, 6 is somewhere there. We're not quite going to get all the way around the circle if I do that 6 times. So 1 radian, 2, 3, 4, 5, 6, and it's not quite accurate. That should probably be a little bit further up the line there, but the idea is that in order to get all the way around the circle, I should have 6.28 radians, I'm going to call it rads, to get all the way around the circle. So 360 degrees is 6.28. That's also known as 2 pi radians. So if we were to go all the way around the circle, that's 2 pi radians. If we went halfway around the circle, you can see I got 1, 2, 3 point a little bit, 3 point, so like 3.14 hypothetically, or 1 pi radian. So halfway around the circle is pi radians, all the way around the circle is 2 pi radians. So with that in mind, we're going to draw these angles. So 10 pi over 9. Well, we know that if we went, let me get a little bit better color here. If we were to go around the circle, remember, standard position means that our initial side, we're going to draw in the initial side here, and the terminal side, the ending, if we were to just go around 180 degrees, that would be 9 pi over 9, right? Because that reduces to just pi radians. So if we went 9 pi over 9, we're at 180 degrees right here. But we need to go 1 more pi over 9, which is a pretty small piece, right? That's not really that much further than 180. So I'm going to draw this in, and we go all the way around like that. And I'm going to label that 10 pi over 9. Draw the angle given in standard position. So again, you always want to make sure that you have shown the initial side. It seems tedious, but let's go on to the next one. We'll do another color. It does not matter what the angle is. We always start with that standard position. We always draw an arrow straight over to the right. So this one here is 11 pi over 6. So we're really, really close to, if you look 1 more pi over 6, we would get 12 pi over 6. Well, that's also equal to 2 pi. So we're really close to going all the way around the circle, right? Because if we went 12 pi over 6, that's a full rotation. We are not 12, we're just 1 pi over 6 shy of that. So I'm gonna kind of draw that out as, again, just an estimation. But then you have to make sure you draw that little arcy circle thing to represent that that's the angle. And then we call that 11 pi over 6. See, so it's really simple. Let's keep going down the line here. I already said previously and got ahead of myself going to the right. That was number 4. Let's look at number 3 and go in order here. 3 pi's over 4. Well, 3/4 pi means, well, you know, there's 1 pi over 4, 2 pi over 4, 3 pi over 4, and then 4 pi over 4 gets us 1 pi. So if I erase those, if I go to draw this, maybe I'll change it to this color. Standard position, right? We kind of darken that in to represent our initial side. And then 3 pi over 4 we determined is 45 degrees off this direction. So we 3 pi over 4. We label it and we show kind of that little line directing us as to what direction that angle is. We did number 4. 2, 3, and 4 are very similar to each other. Looking at number 5, it is a negative in front. So all that means is, well, first of all, let me get a new color here. All it means is we still start standard position over here, straight to the right, but instead of going counterclockwise, we will rotate around the circle this direction some amount. So let's see, 4 pi over 3, 3 pi over 3 gets us to 180 degrees. So we are 1 more pi over 3 units past that. So 1, 2, 3 gets us 180, and then another pi over 3, we're at like 1/3. 1/3 of the way back around the second half. So I'm going to call that good. Call that. I already made the same mistake I just told you guys not to do. Make sure you draw the arrow in the correct orientation of the angle, right? So that arrow, maybe, let me even do this. I'm going to change the color of that to highlight it even more. There. So that's that negative direction, 4 pi over 3. 7 will be the same, but let's look at 6 real quick. 6, we are almost 24 pi over 6. That's a lot of rotating. Let's go to this purple. No, we better go. So I'll just go back to the orange. Standard position, like that. 23 pi over, okay, so 24, let me see, what would that look like? What would 24 pi over 6 look like? That's really close to 4 pi. 4 pi would be going around the circle once and around the circle again, but we don't quite get all the way that far. What we do get, though, is just 1 pi over 6 short of that. So we are going to draw out like a pi over 6 angle like that. Okay, but when we draw our circle, our little arrow, what I'm going to do is I'm going to say, you know, here's 6, 12, 18, 23. There. So you do actually do that little snail coil to represent that. So please make sure you're showing those as you draw them. Number 7. 7 is, I guess it's the last one. It is the toughest one. Here's what we're going to do, though. We're going to say standard position. We'll go back to red. Standard position here. Initial side. Now, we are going to have to go backwards, quote unquote backwards. We're going to go clockwise around this thing. And we're going to find that if we went, 18 pi over 18, 36 gets us all the way around. 36 gets us 1 full revolution, 36 pi over 18, or negative. So if we went to the next, if we went all the way around to here, that's 54, because if you add 18 3 times, you get 54. We know that we're short of that. We're at 49. So we're somewhere shy of this getting back to the horizontal line. And if you figure it out, you're about 5/18 away from it. So again, that's going to be a little bit of an approximation, but I'm going to approximate it as being about like that. You can kind of do, there's different ways to figure it out, but I'm going to continue that line around to there. That's negative 49 pi over 18. So again, there's a few ways to get that, but the best way to do it is, you can even get in your calculator and just take 49, hit enter, minus 18, so that's halfway around the circle. I still have 31 18ths left, so halfway around gets us that. We made one full revolution by going 2 18s, 18 and 18. We're left with 13 18ths. So what I'm saying is we went 18, 36. After 36, I have 13 18ths left. So 13 18ths puts us about right there. Anyways, that's it. That's 2 through 7. That's plenty. I will do another video for the rest of the problems.